Uh, so I decided not to talk about the French network because I think you have an idea of what is a seismological educational network. Just I will want to show you some real things into the classroom using data or using seismology at school. And it's this one, yes? Okay. And just, well, to begin, of course, the first question, because we began 20 years ago, so it's a very old network now. And our first question was, this one is always the same for everybody, so how we can improve education of a population using the school. And we thought that it is a main question that a teacher have to resolve this question at school. And of course, the second question is how we are going to teach seismology for a better understanding of Earth and of course of a seismic risk. You have to know that in France, we have geoscience teacher. So we have seismology, it's in the curriculum, not for a long time in the year, so maybe 4 weeks, but geoscience teachers are there to teach earth science and, of course, seismic risk. Of course, we can involve geography, mathematics, physics, computing teacher also. So I will want to show you what did we learn about the teaching seismology during this 10 last year in France. So the first thing that we began a long time ago after PEP project, John talked about this project managed by Gus Nolet in Princeton, and we choose this idea to install seismometer at school. Of course, it's not the only way to educate population about the seismic risk, but it was our choice 20 years ago. And in fact, you see the first experiment. So students recorded earthquakes directly at school. So I think it's a good way. It's not a bad idea because the seismology at school in France is still ongoing. So that means after 20 years, we have schools who are always involved, and all the students say that seismometer is an amazing tool at school, and they record things. Of course, the first key point that we learn is that if we install seismometer, we have to provide, well, to install seismometer in a network. So you can see the French network. So you can see, well, France is only this, okay? Maybe the Caribbean. So in fact, we use also the French school in other countries. We have a huge network of French school in every country. And so we install seismometer in the French school, so we have a worldwide network, okay? But it's not only this. We have also to get the data and to build a data for education. A lot of time, I'm not a researcher, but I discuss with researchers, and they said, well, it's very easier to find the data on your website than in another website. Don't ask me the name of the other website but in fact, the education community wants something very simple, very clear to find data. So you have to think about how you are going to provide the data for the community of the schools. And so it was our first goal to make a website with a specific approach for education. So it was our first lesson about this network. The second one is that the choice of a sensor. Well, Michel or John talk about this. Which choice? Of course, actually we have a huge choice. Black box or something very simple. So you see things, maybe you know the TC1. You don't know this, of course, because it's our French sensor to make some experiment, but I encourage you to see these people. Jeremy there, he can show you the sensor, very easy to use at school. And in fact, the second lesson was this one. So people are very, very exciting by a seismometer. But in fact, we have to know what the teacher wants to use from the sensor. And you can provide the choice. So the teacher asks for a seismometer, and our first question is to say, you want to do what with a seismometer? And depending on the answer, we can provide black box or not, depending on the choice of a teacher, or pedagogic choice of a teacher, of course. The third, it was data is nice, seismometer is nice, but after the data you need software. And it's the same thing. So teacher cannot use a lot of software coming from the research community. So we have to provide software. Sometimes we have to create software specifically for education. You know Seisgram 2K, I guess. People said to me that Anthony Lomax will be there tomorrow. But we have a school version, a special school version of Seisgram 2K with more colors, with things a little more funny, of course. You know Jamaseis, of course. EduCart, you don't know, maybe it's a geographical information system for schools, for using the data, because sometimes we have to plot the data to see a subduction zone or things like that. So we have create with Anthony the EduCart. And so, of course, we need to create and to provide things to use the computer. And one of the success of our network is the informatic aspect, because, of course, people gave us money to deploy all the seismology at school, not only for seismology, but also to use computing and to use data, because it's also another goal in the education to use data. The fourth key point, it's that the students are not very always happy in front of the computer. Sometimes they ask, well, this knowledge is very difficult to understand. And so I need to make some modelization. And so we provide a lot of kit, box, with very, very simple things, because the student need to experiment by themselves. Very, very, very simple. For example, if you want to model an earthquake, we use lasagna. Yes, lasagna, Italian lasagna. Yes, but not cooked. Okay. And we make some rupture like this, because usually before a teacher is doing this for an earthquake. It's not a good example. The example is to make a rupture. So you can use this. If you are in Switzerland, you use chocolate, of course. Chocolate from fridge, or chocolate from... and so you see if a chocolate, it can be more or less soft, and so you can make relation between amplitude of your sensor, and you can use only piezo cell microphone. So it costs nothing, and you can show the relation between the rupture and the... So we have made a lot of things, box like this, and now we are making a box for InSight. So you will see all the hands-on activity, because it's our specialty to make hands-on activity with the data, with a USB key. If you are very kind and if you are involved in the school, maybe we will give you a key where there is software, hands-on ideas to deploy resources like this. I go, the five key points is the teacher needs to share ideas, because each school is working alone. Sometimes they are in contact, but the workshop can help to share things. And coming to InSight, I will want to show you what we have done with InSight. So the resource of InSight We have some topics like data, telluric, journey, because how we travel from Earth to Mars, sensor, and also signal, how we transfer signal. Of course, I am going to show you an activity, a real activity, what we have done using the network, the French network. You know, or you must know, that the researcher community has made a challenge, the blind test on Mars. So it's synthetic data during 1 year. And so the researcher actually, until the 19th of February, yes, they have to make the catalog of a seismic event that they have found in the data, with synthetic data, and making tools to be able and to be sure that when the real data will come on the Earth, we will be able to pick event, okay? And so we decided, the French seismological educational network, so the French school, decided to challenge this. But of course, it's too difficult for us to pick. So in fact, we have used this to make a special approach using the data. And so I can show you the step. The first step was to give to the student a sampling of a signal. So 2 Hertz, it will be the data coming from Mars. And this is an earthquake on the Earth with 50 Hertz sampling. And we gave to the student the same signal with 2 Hertz, just to show that it's not the same. So the student has to notice that the frequency of the sampling is give seismogram very different. Not mainly for the local earthquake, because for a faraway earthquake, it's not so difficult. The second step, it was to learn how to filter. So they learn to filter. Of course, they know that the P waves is something like 3, 4, 5 Hertz, and the data is only 2 Hertz. So wow, how we can manage this? So they have made bandpass filter. They decided how we can filter, and then they see that okay, it's not the same, because after filter I can see this, I can see this, okay. And so they use the software seismogram to do this, because all the data are in SAC format. Then, first step, student alone, because they have only 1 month to do. Each school has 1 month. There was 15 schools, but 1 month per school. This school, it was a French school in Shanghai, have made I made this, so each day they have seen this noise, and each day it's the same time, but 40 minutes later, each day. And so they don't know why, they ask questions. So one researcher involved in meteorological aspect of InSight mission answered to the student. He say, okay, on Mars, you have every day movement of turbulence. It's a thermal tide, so that means that the sun is heating the atmosphere of Mars, and so we have noise with turbulence of the weak atmosphere on Mars. So that means that the students say, okay, so it cannot be an earthquake, it's too long, so every day we have this. Why 40 minutes? Because the day on Mars is 40 minutes late on the Earth. And so, of course, they see that this is not seismic event, it's just the noise of the environment. And then the third, so they selected only something outside the noise, because they decide that the noise is too difficult. And so after they learn to pick the Rayleigh waves to see the R1, R2, R3. I think you are used with this. It's just to calculate the distance, because Mars is a little one planet. They find distance, because they use a seismogram. And to finish, how to estimate the azimuth of a seismic event, they use accelerometer. So you can see this, we have a sample here. So with 3 components, and so we learned that depending of the orientation of a shock, yes, you will see this on the horizontal component. So if we look at the horizontal component, even on the Earth, you can calculate the azimuth. And so if I know the distance and the azimuth, I have a location only with 1 station. Thanks.
Thank you very much. So if anybody has any questions, please raise your hand. Go ahead.
I think the InSight stuff could be used beyond just InSight for looking at earthquakes within the school. Earthquakes, not Mars quakes. Is there any plan to sort of share the steps that you've gone through with this?
If I well understood, the question is to know how the data from Mars are using not only for Mars but on the Earth too. In fact,
so
we
training kids
exactly
there too.
the same exercise with the data from the Earth and Mars, but the students are very exciting because it's data from Mars.
But not everyone's going to be able to see that.
Is that on Mars? And say, yes, but it's the same. And we do also exercise from Moon with Apollo mission. So when you make a triangulation on the Moon, it's the same one than the Earth, but with the space is something. So the idea is to provide a lot of resources using seismology, but not only, because on InSight lander, you have meteorological station, and you have also a thermometer. And so we use seismic InSight mission to do more than seismology. And so the idea is to provide resources for the schools. Of course, it's difficult because we produce resources for the French school, because we have a special curriculum. So after, it's not only question of translation, it's question of transfer things to be completely integrated to the curriculum of each country.
Thank you. John has a question. Yeah.
I thought people were being asked to create a synthetic catalog for Mars, but it sounds like there already is a standardized synthetic catalog that anyone's allowed to access and use. Is that what you're using with your students? Where is your synthetic catalog coming from that you're using?
Synthetic data?
Yeah.
Well, when you apply for the blind test,
Yeah.
you have an access to the data of the blind test, 1 year. So we take the catalog, we cut the catalog each 1 month, and so 12 months, and we say on the network who wants to participate to the challenge. In fact, it's very important for us because we know that we are going to select schools for the first period of the data. So we want to know also in the network who are more involved in this thematic with teacher, very dynamic. And so each school has had 1 month to analyze and to study. And the catalog, well, we deposit the catalog today. Maybe we are going to win. No, the catalog is difficult for the students, but the idea is to make the pedagogic approach. Yeah.
Thank you. Any other questions?
Open competition to the seismology community to try and understand that data set. Right. Put it out. I misread. I thought it was to create the data set. You should add to your slides that you're ready for InSight, but InSight isn't ready for the schools.
True. Okay?
Okay.
Thank you.
Thank you very much. Thank you.